This video is going to cover solving quadratic equations using the quadratic formula. This specific video is a little harder than the last one. You notice the last one we had rational numbers as zeros or roots or x-intercepts or solutions. Okay? What that meant was we either had a fraction or an integer. Here on this specific video, we're not going to have either of those as roots or solutions or zeros or x-intercepts. What we're going to do is we're going to have irrational roots. Okay? That means we're going to have a square root in our answer, and we're going to have to know how to simplify and break it down and make it smaller, make it a little nicer for us. So first thing is, what is the quadratic formula? You recall from the last video, it stands for the variable, whatever it is. In this case, it's k. This could be v, and the next one it could be p. Doesn't really matter. This is what really matters. Negative b plus or minus the square root of b squared minus 4ac over 2a. That is our quadratic formula. That is something that not necessarily has to be memorized. It needs to be known. You need to write it down 15 times. Write it in your notebook every time we're doing it. We also have access to this on the board as well during assessment. So what do I need to do? Same thing before. I need to make sure that's 0. That is 0, so that means this is a, b, and c. Now let's substitute. Opposite of b, negative 3, plus or minus square root of 3 squared minus 4 times 11 times negative 12 divided by 2 times 11. So let's now figure out what happens. We get negative 3 plus or minus the square root of 9 positive 528. How do I know it's positive? Well, there's a negative there and there's a negative there. Two negatives make a positive, so I get the plus. 4 times 11 times 12 is 528. Divided by 22. So let's keep on going. I get negative 3 plus or minus the square root of 537 divided by 22. Now what I have to do is see if 537 is a perfect square. If you type it into your calculator and you hit the square root button, you're going to get somewhere in the neighborhood of like 23.17 da da da. That means it's not a perfect square. Different strategies that we used a couple videos ago was that I told you how to break down a number into its prime factors. So 537, break it down. What can I divide it by? 3 divided by 3. So 537 divided by 3 is 179. Can I break down 179 at all? Well, let's see. I can't break down 179 because 179 is also prime. So I have two prime numbers. That means, because I have no pairs, the 537 is going to stay inside. For those of you that were in honors, we did it a different way. I took the 537 and I wanted to find out if a perfect square goes into it. So 1 times 537, that goes in. But the next one is 4. That doesn't work. The next one is 9. That doesn't work. The next one is 16. And then 25 and 36 and 49. None of those work. So that means the 537 again has to stay inside. So what happens with my answer? Because nothing popped out front of my square root, my answer is exactly as it appears. That is my answer. Again, in curly brackets. Now, in the last video, you're like, well, I had 2 answers. How come I only have 1 here? Well, technically, you do have 2 answers. Remember, you have the positive version and the negative one. So you can write it that way as well. Either of those answers are okay. This one is shorter, this one's a little longer, but that's okay. Either is fine. Okay, this particular problem has an x in it. So my quadratic formula is now going to be x equals all of that. So again, the first thing I need is make sure this is 0. It is. Yay! A, B, C. Now let's figure it out. Negative 12, opposite of B, plus or minus the square root of 12 squared minus 4 times 1 times 6 over 2 times 1. All I did was plug in numbers. Negative 12 plus or minus the square root of 144 minus 24. 4 times 1 times 6 is 24. Over 2 equals negative 12 plus or minus the square root of 120. 144 minus 24. All over 2. Now I have to try to break down 120. It's not a perfect square, so I have to break it down. So if you were in early college, this is how we did it. So that's how we did it in early college, and you can go from there. Okay? So that is that. Let's do that one first. So what happens is I get negative 12 plus or minus. Remember, I have pairs of 2's. So one of them pops out. The other one, again, gets lost or thrown in the garbage or whatever, you know what I mean? And then 2 times 3 times 5 is 30 over 2. So we'll leave it there for right now. Let's go back to how we can factor the 120 with the honors classes. So 120, remember we talked about perfect squares. That's 1 times 120. Yay! Then it's 4 times 30. 9 doesn't go into it. 16 doesn't go into it. 25, 36, 49, 64, 81, 100. They don't go into it. So this is my biggest perfect square. So the square root of 4 is 2, and the square root of 30 is the square root of 30. So you notice how I got 2 root 30, it's right there. If you worked in college, in my early college or my honors, you still get the same answer. So my answer looks good, but there's one more thing that I need to do. If I look at the negative 12 and the 2, and this 2 and that 2, the top 2 and the bottom 2 there, because those are monomials, okay, I can simplify them all and divide by 2. All 3 of them have to go into the number that you want to divide by. If one of them was a 3, then I couldn't divide any of them by 2. Okay, all of them have to be divisible by whatever you want to bring out or take away. So because I'm dividing them all by 2, so my answer goes like this. Negative 6 plus or minus 2 divided by 2 is 1. I don't need to write it. Square root of 30 divided by 1. But if I divide anything by 1, what actually happens? I'm left with what's on top. So my answer is negative 6 plus or minus root 30 in curly brackets. Again, if you wanted to write 2 of them side by side with a comma in the middle, that's okay. This particular problem has an A in it, so it's A equals all of that. Okay, so the first thing is this 0. No, so I have to do minus 6. 7a squared plus 10a minus 7 equals 0. Plug it into my equation, my quadratic formula there. Negative 10, opposite of b, plus or minus the square root of 10 squared minus 4 times 7 times negative 7 over 2 times 7. Let's start simplifying a little bit. Negative 10 plus or minus the square root of 100 plus 196. 4 times 7 times 7, and then 2 negatives make a positive. Divide by 14. So what happens is when my parentheses, I get negative 10 plus or minus the square root of 296 over 14. So I need to break down the 296. So if you were in early college, remember 2 times 148, 2 times 74, 2 times 37. Prime, 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 prime. If you were in honors, in order to break down the 296, I have to find perfect squares. 1 times 296, 4 times 74, no 9, no 16, no 25, no 36, 49, 64, 81, 100, 121, 144. None of that. So the biggest one is here. So the square root of 4 is 2. square root of 74. Same thing if I use the prime factorization. These are both in pairs. One comes out, the other one gets crossed out. What am I left with? 2 root 74. Negative 10 plus or minus 2 root 74 over 14. If I look at the numbers again, I can divide them all by 2. So here is your answer. Negative 5 plus or minus. I can write a 1 here if I want to, doesn't matter. So, square root of 74 divided by 7. Again, put it into curly brackets. You could write it as one answer combined, or you can separate them out with a comma in the middle. It is up to you. Particular equation, I have the variable a, so that's going to go there. Then I, again, need to make sure I have a 0 here. I don't, so I need to minus 7. So I get 8a squared minus a minus 6 is set to 0. So again, I have a, b's, and c's. I'm going to start plugging them in. So b is negative 1, so the opposite of it is positive 1, plus or minus. The square root of negative 1 squared, again, see parentheses around the number, minus 4 times 8 times negative 6, all over 2 times 8. So now let's start simplifying. 1 plus or minus square root of 1 plus, how do I know it's a plus? I have 2 negative numbers. Then I multiply 4 times 8 times 6, and I get 192 divided by 16. Now I go further. 1 plus or minus the square root of 193 over 16. What I then have to do is see if I can break down 193. I cannot divide it by 2. Can't divide it by 3. I can't go divide it by 4 and 5. I can't divide it by 6 or 7 or 8. And if you keep on going, you actually realize that you can't divide 193 by anything. Whether you do it with the prime factorization method or you do it with the finding perfect squares method. Okay, so therefore, since I can't find anything to come out of it, my answer is the same as what I have there. Again, I need curly brackets. This equation will conclude this video, solving quadratic equations using the quadratic formula. So on this particular problem, again, I have a as my variable. I need to then make sure this becomes a 0. How do I do that? I have to add 8. So I get 7a squared minus 8a minus 22 is set to 0. I have a, b, and c already given. Now let's start plugging in. So I get 8, remember the opposite of b, plus or minus the square root of negative 8, again in parentheses, minus 4 times 7 times negative 22, divided by 2 times 7. Now let's start simplifying further. 8 plus or minus the square root of 64 plus 616 over 14. All I did was multiply 4 times 7 times 22. Again, it's a positive because I have 2 negatives when I multiply. So now let's combine the numbers inside the root. 8 plus or minus 64 plus 616 inside the root is 680 divided by 14. So I need to take the 680 and start doing my prime factors. 2 times 340, 2 times 170, 2 times 85, 5 times 17. Prime, 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 prime. That's the one way with the prime factors if you were in early college. If you are not in early college, remember we talked about finding perfect squares. So we always get 1 times 680. Then the next one is 4. 4 times 170 is going to equal 680. And if I keep going through 9, 16, 25, 36, 49, and so on, I'll realize that 4 times 170 is the highest perfect square that goes into 680. So the square root of 4 times the square root of 170, so 2 square root of 170. Same thing here with these 2's. One comes out, the other gets thrown away. So now let's rewrite it. 8 plus or minus, the number that popped out was 2. The numbers that stayed in added or multiplied together to get 170, divided by 14. Now, if you recall from previous problems, the 2 in the 14, the 8 in the 14 can all be reduced by 2. So I have to do that. If one of them wasn't able to be reduced by 2, guess what? I can't reduce them by 2. It has to be all of them. So I get 4 plus or minus 1 root 170 over 7. This 1 doesn't have to be there. It can if you wanted to. It's the same thing. So that's my answer in curly brackets. If you wanted to split it up and do the positive comma the negative, that's totally fine as well. This concludes solving quadratic equations using the quadratic formula with irrational roots. The next video will deal with unreal roots, so complex imaginary roots. So if you need help with that, stay tuned for the next video.